Example A, you learned how to average the x-intercepts to find the vertex of a parabola if its equation is in factored form. We're going to do an investigation to discover how you can complete the square. And again, you did this back in Algebra 1, but I'm going to pretend we've never seen it before and just kind of reteach it. So in step 1, it says, complete a rectangle diagram to find the product of x plus 5 times x plus 5, which is x plus 5 squared. So watch what we're going to do. We're going to label the rectangle on the outside. And I want you to really sort of stop and think here a moment. Like this side represents the length of x plus 5. And this side represents the length of x plus 5. So when I multiplied, you do x times x, which is x squared. X times 5, we don't leave it like that. We would write 5x. Then I'm going to take 5 times the x, and then the 5 times the 5. So what I get is x squared plus 5x plus 5x plus 25. And if I collect like terms, that is x squared plus 10x plus 25. So I'm just using a rectangle instead of us doing FOIL, okay? This is not anything new, okay? It's not like, oh, I've never seen that before. All right, in part B, now look at the second box. It has an x squared, a negative 8x, a negative 8x, and a positive 64, excuse me. What would have been the binomial squared that would represent that picture? Anybody? Yeah, Jillian? Yeah, x minus 8 times x minus 8. And then if I want to write it as a quantity squared, I could then condense that to x minus 8 squared. Okay, do you see that? Do you see that's where it was coming from? That this was an x and this was an x. This had to be a negative 8 and a negative 8, right? So that's it. Letter C. Use a rectangle diagram to show the binomial factors for the perfect square trinomial x squared plus 24x plus 144. So I want you to label the outside of the rectangle and then the 4 boxes. Yeah. A bad glare. Let me fix it for you. Thank you. Is that better now? Yeah. Oh, you're welcome. You're welcome. Okay. All right, who can help us out here? What would I need to label on the rectangle that would eventually give me x squared plus 24x plus 144? Becca, what do you think? Yeah, look, this is going to be an x plus 12. So that would give me x squared. You see a 12x adds up to 24x. And then 12 times 12 is 144. So that would, in fact, give me x plus 12, the quantity squared. This is referred to as a perfect square trinomial. A perfect square trinomial means it started as a trinomial, but when I factor it, it's a quantity squared. The same thing times itself. So when you're hearing me say a perfect square trinomial, that's what I'm talking about. So it says describe how you would do a plus b, the quantity squared. So let's put the a in the b and the a in the b. And I want you to fill in the rectangle. All right, so Wyatt, what would go in the top left box? A squared. There we go. All right, Gabe, what goes in the top right box? BA, or we would call it AB. Usually we do it alphabetically. All right, Davey, what goes in the bottom left box? How about bottom left? BA, or we're going to turn it around to AB. And then Lawrence, what goes in the bottom right? We wouldn't say BB, B squared, right? Yeah, B times B. So this is A squared plus AB plus AB plus B squared, which is A squared plus 2 of the ABs plus B squared. So what I want you to notice, okay, because you can do this the easy way and you can do this the hard way as we eventually begin to factor these and undo them, is do you notice that it is A being squared, it's B being squared, and then if you take the A times the B and double it, that gives the middle term. That's what 2 times A times B is. So come back here, and do you see my A is X, and my B is 12, okay? The A is X, and the B is 12 here. So X squared is here, 12 squared is 144, but 2 times X times 12 is the 24X. And then if I come up here to where you would have, that's X squared plus 10X plus 25, you see that is the X being squared, the 5 being squared, and then X times 5 times 2 is the 10X. That's called a perfect square binomial. So you've got to remember, it's the first term squared, the last term squared, take the first and the last and double. That always gives the middle. That's the big idea there. All right, so here's step 2 in the investigation. It said, what if I only had x squared plus 6x and I want to make it a perfect square trinomial? So look at the box to the right. What number would I need to put in there to make it a perfect square trinomial? Ella, what do you think? It would be 9. Yes, it would be 9. So here's the big idea. So like we're eventually getting somewhere with this, okay? But I'm taking you real slowly through the process, okay? So here's the big idea. My expression was x squared plus 6x. But if I add 9 to complete the square, technically I have to subtract the 9 to keep it equivalent to x squared plus 6x. Okay? Because it's not an equation. I only have an expression right now. So watch this. So you would do x squared plus 6x. I would add 9 and subtract 9. Then this first piece is x plus 3, the quantity squared, minus 9. Now, where did the 3 come from? That's the most common mistake I've heard over the years. They're like, where do you get the 3 from? Where's this 3 coming from? Yeah, Angela? Yes, okay, that middle term, excellent. Okay, that middle term, 6x, is split into 2 things that are the same. So it'll always be half of this number because it had to be 3x plus 3x to add to the 6x. All right, so now I want you to watch me. I'm going to pull up my Desmos, and I'm going to put both of these in here. I'm going to put, okay, I'm going to put x squared plus 6x in, and I'm going to put x plus 3, the quantity squared, minus 9, and I'm going to show you they're the same. It's actually the same graph. So let me go to my Desmos. Here we go. All right, so I'm going to put y equals x squared plus 6x. Okay, so do you see that? And then I'm going to add my other one and put x, what did I get? Plus 3 squared minus 9. Look, it's the exact same. So so it's sort of like, you know how sometimes you can have the number 10 and you could have 20 divided by 2. It's the same thing, okay? It's just written in a different way. So, extra practice. I would like you to figure out, now I'm not doing this where I'm going to add and subtract yet. I just want to know what is the number I need to add to make it a perfect square trinomial, and then what is the quantity squared. Try these two for me. Let me give you about a minute. Try both of those and fill in both blanks. All right, talk at your table. Share what you put in each of your blanks. Because then I'm going to call on somebody and I want you to get it right. All right, let's go ahead and talk. Abby, what did you put in your first blank? X squared minus 10x plus blank. 25, okay? You're going to get 25. And then, Sydney, what did you put? X minus what?
X minus 5.
Good job. Okay, so think about it. If you need to, draw a rectangle. Okay, if you need to. And you can always do this. So you would want the x and the x, but in order to get a 10x, these had to be negative 5x's to add up. So that's where you're getting the minus 5s. And then negative 5 times negative 5 is 25. Okay? All right, how about in letter B? Maddie, what did you put? X squared. This one was a little bit trickier. It was written differently. X squared minus blank x plus 36. You said 18? I did not get 18. Bella, what'd you get? It's not 18. Okay. Yeah, Becca? It is 12, okay? Because what time, so think about it like this, okay? So think about your rectangle. The x and the x will give you the x squared. What times itself is 36? 6, okay? So then that's going to give you, this has to be the 6 and the 6. Now it is a minus, so then those are going to be minus 6x minus 6x. Does that make sense now? Okay, good. Okay, because I did think that I was asking it a little differently, okay, just coming at it from a different direction, and it's okay. Like, remember that little quote I had yesterday about the sweating in basketball? Like, you're learning. Getting confused, that's a good thing. We need to remind ourselves. It's good. When I'm confused, that means I'm learning. I'm learning something, okay? I know it doesn't feel good, but it really is a good thing. All right, so now, and again, this investigation, I'm going nice and slowly, okay? Nice and slowly here. And then on Monday, we'll really piece everything together. But today, I'm just trying to lay an awesome foundation. All right, step 3. Consider the expression x squared plus 6x minus 4. All right, so what you're going to do, because eventually we're trying to be able to solve equations, quadratic equations, by completing the square. So we're trying to come up with the x plus something squared. So it is normally not nice, so we've got to figure it out. So what you do is in part A, you focus on the x squared in the x, and you ignore that minus 4. Okay, you're going to ignore the minus 4. So what you're going to do is you're going to look at the x squared just at the plus 6x. So I know by my rectangle over here that has to be a plus 3 and a plus 3. So what do I need to add to x squared plus 6x that makes it the perfect square trinomial? Anybody? 9, right? Because it has to be the 3 times the 3. So if I add 9, okay, now here's where my minus 4 comes in, and then I actually have to subtract the 9. Because you can't just randomly add a number, okay? You just can't do that in an expression. So this would become x plus 3 squared minus 13. Okay, this piece right here is represented in x plus 3, the quantity squared. And again, I'm trying to go real slowly here because I've taught over 30 years, and I have students every single year that I do this go, what happened to the 6x? Where did the 6x go? The 6x is in here. It's x squared plus 3x plus 3x plus 9. That's packed in, the x plus 3, the quantity squared. It is in there, but students have a misconception that this is x squared plus 3 squared, and that's false. So I'm trying to go nice and slowly. Can we get that in our brains? You get it? You get that this x plus 3 squared is x squared plus 6x plus 9. That's how it multiplies, okay? All right, I'm not going to verify it because I know it's true. All right, so let's go to step 4. All right, step 4, this is just one more. It says we want to put it, do you see that's vertex form, or really close to vertex form? X minus h squared plus k. I just didn't put an a value in, but we're going to get there. We're going to get there. So it says rewrite it in this form using a rectangle diagram. So what you're going to do first is we're only going to look at x squared minus 14x. Can you label the rectangle that'll build that? All right, is there anybody who's getting the hang of it that can tell me what goes across the top and then the left side? It's going to be the same thing. What am I going to put on my rectangle? Oh, good job, Daniel. Tell me what to write. I see it. No, I want the above the rectangle. I see what you have. It's beautiful. Yeah, the x and the minus 7. There you go. Okay, so, and then you were filling it in for me. X times x is the x squared. I need a negative 7x and a negative 7x. And then what's going to go in that bottom right box? 49, and it's positive, right? Now, here's the connection, because eventually we don't want to write the rectangles, but you can always write the rectangles if it helps, okay? That's always okay. But when we get to an Algebra 2 level, we want to be able to get a little more abstract with it. And what I have happening here is, can you tell that this number is always half of this one? Have you caught on to that? This number is always half because I need 2 of them. Yeah, Angela? Okay, I just dropped it for a moment, but great question. So great segue. So watch, here's what I'm going to do. To complete the square, I need to add 49. So that's going to be my thing I want. But you're absolutely right. I have a plus 3, but I got to subtract 49 because there really isn't a 49 there. So then this piece becomes x minus 7 squared minus 46. So what I'm saying, here's the big idea. What I'm saying is x squared minus 14x plus 3 in a vertex form looks like this. So do you remember how we've been talking about when we had factored form and we knew the x-intercepts, we could get to vertex form? Now I can go from the general form to vertex form with completing the square. Yeah, Bella? What's negative? Oh, okay, great question. So do you see that in order to make x squared minus 14x plus 49, in order for me to make it like this, we added the 49 to the x squared minus 14x, right? There's no 49 here. So when you add 49 and subtract 49, do you see this net effect is 3? 49 plus 3 minus 49, that whole thing adds up to 3, right? And so then this statement is equal to x squared minus 14x, but I have to make it equal, okay? And then, so this piece goes down to x minus 7 squared, but 3 minus 49 is minus 46. Great question, great question. Okay, all right, we're going to skip part B. All right, so now what do you do if there's a number in front? Okay, what do you do if there's a number in front? Well, the good news is you're going to factor it out, and then you're going to ignore it temporarily, okay? So watch this. If I have 3x squared plus 24x plus 5, you're going to, and I've already worked this one out. I factored out the 3, so I made it x squared plus 8x. You see that? I'm doing nothing with the 5. It's hanging out. Then I make my box with x plus 4, x plus 4. So I'm adding 16 on the inside. But now I got to pay attention to that 3. It's actually 3 times 16, which is 48. So then I've got to subtract 3 times the 16. And then this factors 3 times the quantity, x plus 4 squared minus 43. All right, so let's actually do one ourselves. So let's look at it, step 5. All right, and this is the hardest that we're going to see. I'm going to factor out the 2 just out of the x squared and the x. Okay, I'm going to factor out the 2. So far, so good. All right, now, if it helps, make your box. I would have an x and an x. And what do the other 2 numbers need to be that would be equal, add up to negative 6? Negative 3 and negative 3, right? Because they add up to the negative 6. So that gives me the x squared, negative 3x, negative 3x, and what goes in the bottom? 9. So watch what we're going to do now in the next row. And I'm going to change colors so you can see it. This is going to be x squared minus 6x, and I'm going to add 9. But then I've got to subtract what I just added because it really isn't there. So then I'm going to take minus 2 times the 9 plus 1. And it doesn't matter if I did the 1 and then the minus 2 times the 9. Okay, it's the same. So then this is 2 times the quantity, x minus 3 squared, minus 18 plus 1. And that's what? 2 times x minus 3 squared minus 17. So this is coming up with vertex form from general form. That's what we've actually done. Angela? Great question. Okay, do you see, that's an awesome question. Actually, I think that's similar to Bella's question. So do you see here that I have 2 times x squared minus 6x plus 1, and that's equal to this line above, right? Okay, so now, when I added the 9 inside, it really was 2 times 9, so I'm adding 18. You are So if I add 18, I have to subtract the 18 to make it equal to this line here. Does that make sense? Okay. But the reason why I'm adding, the reason why I'm adding 18 is because I want to write this as x minus 3, the quantity squared. And then I can tell the vertex from it, okay? All right. The big idea for step 6, here's all I want you to write here, okay? If you have y equals ax squared plus bx plus c, you learned this back in Algebra 1, and I just need you to remember it. And so instead of me developing it, I am going to just tell you what it is. So one method is doing the completing the square. A second method from general form to the vertex is that if it's y equals ax squared plus bx plus c, we had this other formula, x equals negative b over 2a. Is that coming back to you? Good. Seeing some good nods there. All right, so what we just figured out, though, is we figured out the process of completing the square. So let's try example B, letter A. Okay, let's try this one. It says you want to convert y equals x squared minus 18x plus 100. All right, so your first step, there is no number in front of x squared, okay? So if there is a number in front of x squared, then factor it out first. Make sure you write this down. Okay, if there is a number in front of x squared, then factor it out first. Well, the good news is there is no number out front. So then we're ready to complete the square. So what you do is you look at x squared minus 18x. Okay, what numbers do I need to put in the other spots that would add up the same number when I add it together would add up to negative 18? Negative 9. So I'm going to put a minus 9 and a minus 9. And then what's the number that goes in the bottom box? Positive 81. Good job. Okay? So, excuse me, watch what I'm going to do then. I'm going to add 81, subtract 81, and then I still have this 100 that was hanging out. So then, the purpose of this, okay, the purpose of completing the square, the reason why you want to add the 81 is that made x minus 9 times x minus 9. So then that's going to make it x minus 9 squared plus 19. Now that's vertex form. What's my vertex? How about positive 919? Remember, it's x minus h. Okay, we're going to skip part B. It says, you may find that using the formulas for h and k is often simpler than completing the square. Both methods will allow you to find the vertex of a quadratic equation and write it in vertex form. However, the method of completing the square will be used again when you work with circles and other geometric shapes. We can solve quadratic equations that way. We're going to do example C on Monday. What I'd like you to do is I want you to scroll down and I want you to try the closing extra example on the left. Put it in vertex form. Y equals x squared minus 14x plus 2. Let's see if you've got it now. Okay, we've done several together. All right, I'm going to go ahead and start this one. Y equals x squared minus 14x. I'm going to leave a little space as I try to figure out what I need to do. What numbers do I need to add in my rectangle? Yeah, Davey? -7. Good job. So that's going to be x squared minus 7x minus 7x. And then what goes in the bottom right? 49. So I add 49, subtract 49, plus the 2. Don't lose that pesky little 2. Then that's x minus 7 squared minus 47. That's vertex form, and my vertex is 7, comma, -47. All right, I would like you to pull up the homework. And